Okay, good. So, welcome everyone. As you have understood, we are kicking off today the Sprint 3, which is made of those concepts that are disciplines specific. And so, as a matter of fact, we will split this kickoff in 3 parts. So the first part will be we're introducing to you the concepts that relates to geotechnics. The second part will be those concepts related to excavation support, lining. And the third part will be around those concepts for systems. So half an hour each. That I think the format will still allow for some questions, and I would think we would want to take any questions at the end of each half an hour. Just for your information, we we have altogether around 260 new concepts / properties. And so we had to make a selection. And we made a selection. Good morning, Stefan. We made a selection by trying to pick up concepts that were, quote, quote, typical, if you will, so that if you know how to implement that one concept, it would be easy then to replicate the implementation for similar concepts, not in the sense of what they mean, but in the sense of the way they are structured from an AFC perspective. So we end up with a selection of around 40-45 concepts altogether, and then they will be split in the three disciplines. And so this is what we are going to be presenting you today. Of course, as per Sprint 1 and Sprint 2, things can be accessed through the GitHub platform. Example files can be made available there too. So from that perspective, nothing will has changed. We've just extended. And the checker will be made available to you as well very, very shortly, so that your first submissions can be checked the same way we did for Sprint 1 and Sprint 2. So with that, I think we should start. So taking you through the documentation of those concepts. To start with, the geotechnics concepts that we have selected. Stefan, is that you or is that Lars that starts? Lars, if you are ready.
Okay, I can share.
Will you share? Okay, perfect.
Yes, okay, I hope you see something.
We do.
Now. Okay, great. So as you see, we have it's same structure in GitHub as before, and these 3 sprint specifications have been added. And right now we are dealing with geotechnics, geoscience. And we are continuing as we have done before. We sort of build on what we already have and add new concepts to that. You see the list of new concepts, the concepts that we have added in this list: spatial containment, element decomposition, composition. Product assignment is something that I think hasn't maybe been used that much before, but we make use of it for our domains. We'll look into it a little bit closer. Dataset association is something that we have added in IfcTunnel. And you have already in previous sprints, you have actually declared a data set, which is then an external data set, which we will actually link to a product in this exercise. We have product span positioning, and we can look into that closer. And we have assignment to product, which is the inverse of product assignment. So if we go into the actual domain concepts here, geotechnics or geoscience is divided into these books, A, B, and C. And I'm not a geoscience expert, but we have Jonas and others here from the domain team that can help us explain the concepts if needed. What we have selected for this sprint for book A then is IFC borehole, which is actually the entity was added already in IFC 4.3, but the semantics is slightly modified for tunnel. And some of these things you already know. The IFC borehole should be contained in the IFC site and contained that references spatial containment. You have done that before. Geometry, it says work in progress because Jonas is actually sending a list on expected or required geometries for these objects. So we didn't have that exactly in place. I've also, I should say, made an example file where I have, because I sort of create these example files programmatically, I don't want to use too complicated geometry. So I've just used extruded area solids, which is quite simple to create. So for example, my borehole is just a cylinder, which is sort of an extruded circle. Local placement, you have done that before. All is yeah.
Oh, he's back. Thanks.
Yeah.
Lars, we lost you for a second there with local placement.
Okay. Sorry.
We saw your mouth move, but there was no.
Sounds like the lyrics from a Pink Floyd tune, I think. Your lips move, but I can't hear what you say. Local placement, same concept as before. Since the borehole is contained in the site, it should be placed locally and relatively to the site. And then we have, for each of these entities, there are many new property sets defined, but to sort of reduce the amount of work, we have selected one of the new property sets. So in this case, we have PZ spatial GeoObs borehole, which should be assigned to the borehole. And then we have another new concept, which are observations. Book A is about factual data, and I know that much. So what we actually can see and measure. And this observation is a product as such. It should be the predefined type borehole log in this case, and it should be assigned to the borehole. And then we can look at product assignment or assignment to product. So this is an existing relationship in IFC where you can assign an object to a product, or the product can be assigned objects. So this is the mechanism we then use to actually connect the observation with the borehole as such. the observation should be declared. We have said in the project declared, you have used the declaration concept also in previous sprints. And we should add a property set also to the observation. Then we have dataset information, which is then an external dataset, and you may use, if you have done the previous sprints, you may use sort of the dataset information that you already have declared before. But this, in this exercise, it should also be associated with this observation. So this is sort of when there is data in some separate format. For example, for this borehole log, you can assign or associate that with an object in the IFC file. Then we have something called a mapped zone, and I think to explain this concept, maybe it's best that Jonas or someone in the Geo team does that. But anyway,
yes.
So
no.
maybe you can, you may a few words about that one.
Yes, the map zone. The idea was to to represent any time of any kind of observation that has been made by a geologist or a geotechnician. And this could be, for example, a phase log in the tunnel, where you go and look at the excavated tunnel phase and make your notes, measure discontinuities and so on. Other option would be outside in the field, where you do observation of an outcrop, may it be a natural rock slope or an excavated pit whatsoever. So this is the overall term. We would have subtypes for these mapped zones to say this is a tunnel face, this is a tunnel wall, this is something else. That's it in a nutshell.
Yeah, and again, I mean, these concepts, then it should be aggregated in the site, should have a local placement as everything, and it should have a property set, which we have listed here. And then we have another type of observation mapped feature, which then should be assigned to this mapped zone, so connected to it. And as the other observation, it should be declared in the project. It should be locally placed, and it should have its own property set in this case. And please ask questions if you have any. We have another kind of observation, local information, which should also be assigned to the same map zone in this case. And again, declared in the project. Some geometry, perhaps locally placed, and a property set. As you see, it's sort of the same kind of structure repeating itself here. And to go on with these different types of observations and test them, we have also in situ test results, lab test results, and maybe Jonas could say a few words about these as well, now that you're here.
A pleasure. The test results, that was a big discussion for us, because, as you know, there's a huge amount of geotechnical tests or lab tests and so on. First, we said, okay, we need to distinguish what has been done elsewhere in the laboratory or externally and what has been in place. So in situ is a local test, for example, in a borehole. Any other test would be a lab test. And of course, this can be, as Lars just explained, they should be related to for example, to a borehole, to a tunnel phase, to a location. And of course, there will be a huge number of tests, and we did not distinguish them, but we said this can be handled in the end with custom piece sets relating to certain test methods and so on. So we have only very common attributes on that, but maybe that's already too much detail.
Jan-Erik, you had a question on this?
Yeah, the boreholes, are they just tunnel boreholes, or could they be ground investigation boreholes as well?
This could be any kind of borehole. So of course we need to include investigation boreholes from the surface from anywhere, but also tunnel. But the borehole concept as it is should cover any kind of borehole.
Very good. Thank you.
Artemis?
Yes, actually, I do have a question regarding the tests, the field tests and the lab tests. First of all, there are those that are strictly for rock and those who are strictly for soil. Is there any distinguish between those, or we handle them, in the same way? And then regarding the lab results, there are some methods in the field that do not require to send the sample in the lab, but we do make an observation and bedömning på svenska.
Bedömning, assessment or something.
Assessment, yes.
Yeah.
An assessment in the field. So
But
what
maybe
kind
on
of
a core.
material, for example, we write that on the protocol and we don't need to send that.
Yeah.
So in a software, and when we depict that, for example, in a drawing, we say that this is a sampling. It has soil there with some properties, but this is not sent in the lab for further analysis. So how do we handle this? Will it go under lab results, or it will be regarded as in situ testing?
There's several options. For all of these things, you have different options now. Of course, when you make an observation in the field, you could already put this either on your borehole log or on your mapped zone, because you say, I mapped in this part this kind of material, and I tested it by looking at it and making some field tests with my hammer and so on. Then you can use, as a second option, you can use the point observation that we have. This could be any kind of observation that you make.
I think it's this local information.
It's local information. Yeah. So this doesn't necessarily need to be a test. This can be however you make your observation, but you can use this object to carry any kind of information that you distinguish, for example, in the field directly. And then if I see that example that you find something in the field and you say it's sand, okay, you note this. Then you take a sample, you send it to the laboratory, and you get back the result. And this says, okay, in fact, it's not really sand, it's mostly silt, and it's sandy silt, and you get a grain size distribution and so on. So this would be the information that you can model as a lab test result. So there's several vehicles, let's say, that can carry your information. And the question, if we distinguish soil and rock tests or our samples, we did not do this so far, because we say any kind of classification, this can go in very detailed. Also distinguishing test methods, there's extensive amount of test methods. So what we have included now in the properties is just general properties that are all more or less always needed, like a date, a sample name, maybe a sample category, and so on. But we are aware that there's a lot of custom properties or country-specific, standard-specific properties needed. And this is one point where we think it's very important to stick to existing standards if they are there. So for example, if you are familiar with working with AGS for your samples, you could adopt this. You can adopt the AGS schema with the definition of properties and terminology and so on, create a custom property set and just attach it to the lab test sample or to the lab test results, as we call it now. So
we'll get
lab
back
test
to you on that with the standard later.
Yeah, yes. I think that's an important point for the deployment program now, to see how that really works.
Yes.
And
Yes.
we
It's the same
will
with
have as
boreholes.
well. We will have as well maybe the need to more globally present all the concepts that we are not covering here in the sprint in terms of its implementation, but make sure that people know it is existing and that defined by themselves through the HTML documentation. You know what the other concepts that are not listed here but that are making part of the model, what they are for, and what they embed in terms of properties and so on.
I think we need to speed up a little bit
Yes,
now.
please.
We have 5 minutes, but anyway, I think it's encouraging that we have these discussions, and hopefully they will continue during this deployment phase, because that's what it is for. So yeah, and now that we are really into the different domains, we might need the help of our domain teams that actually know their business, at least more than I do. So just to finish up, we have then Book B separate, and Book B, from my understanding, is then when you have sort of interpreted the factual data and represent it then in the model. So we have two basic concepts. One is a geoscience model, which is a kind of then assembly, which is decomposed by geoscience features, and you have predefined types on both levels. So for Book B, then we should have a geoscience model and a predefined type depending on the decomposition, and we are not exactly sure about the valid pairs here. So here we might also need some input or help from our domain. But then I think it's all known concepts for you now. The geoscience model should be contained in the site. In this case, it should be decomposed by geoscience feature, which we have here below. It should be locally placed relative to the site then, of course, and it should have a property set. We have just picked one here. And then for geoscience feature, which is the then component of the model, you see here it should be part of the geoscience model. It should have a predefined type, and we have listed a couple of them here, and you can pick and choose. So we have here a physical property distribution, geological unit, fault contact, geotechnical unit, hazard area is what we have picked. And then as geometry representation, we have a possibility to use our new concept voxel grid, but otherwise you can use any other body geometry from Sprint 2.3 that we have already had exercises for. Local placement and property sets attached to all of these. One difference is for contact, we have assumed that you should use a surface geometry in that case. And now we have 2 minutes. We have also a Book C, which is then sort of when you move into the actual tunnel design. And there we have one entity that can be used both here in the geoscience domain. We have a Geotech typical section. When we go into tunnel support, for example, you can use also the tunnel typical section for describing support measures in the same way. And what is special about this thing is that it should be positioned between 2 reference. So this is actually something that we describe. It is defined from here to here along the alignment. So it's sort of a linear subsection of the tunnel alignment where you describe certain types of information then. And here we actually didn't have a property set, so maybe we can also take this with the domain team later, but maybe you can start with just representing the entity itself. So it's a normal entity contained in the IfcTunnel, which you have sort of implemented in previous sprints. And the special thing here is that it should be positioned between two reference, and you have this product span positioning concept template here, where you have the typical section, you have two IfcRel positions, and the positioning should be relative then to reference, which you have located along the alignment. So 8:30.
Very good. Thank you very much, Lars. I think we can still take a question or two because we started a few minutes after the hour. If there are any questions.
A quick question from me, just wondering where we got to on any sample data sets from the domain team for the use of the software teams here. Are there any?
I think this is something we've started to compile. Is that correct, Jonas?
Yes, this is what we started, and then at some point we said we stopped because we were not sure how much should come from our side or how much the participants of the deployment program will bring in from their side.
Yeah,
but I'm sure we can find something.
Yeah.
Or
okay. Well,
yeah.
I mean, we'll proceed as with some of our own sample data for this, but and until we kind of hear otherwise. How's that?
And Pat, would that be something you could share with the rest of the team, or is that?
Yeah, well, I think when you get to that, then it comes down to exactly what we hear about, which is formats. You know, what format is the data in? Can I read that format? Can I use that format? So that maybe that's some of the challenge here. So yes is generally the answer. We can share some data that other people can use, but it will come in some formats, and can you use those formats? Yeah.
So the as many documentation as you can publish with it, as you're allowed, we're very grateful. I've also linked in the chat. There is a borehole example from the previous deployment project that links a borehole data set from Australia, I believe. And there is an IFC file in there, but don't take that one as a guidance. That one is according to 4.3 schema, not to the 4.4. But regarding the data itself, it's quite extensive. 30 pages for one borehole, so but it's human readable. So that's usually also the problem. However, yes, if you have any sort of, let's say, reference or other types of formats that you can provide the data in, please do commit. It might be that we'll not have a quality check on that data. We'll just take you by word that it's correct. But you know, whatever helps is of course very welcome.
I think this is a good chance for those who participate to test also their own concepts, or to see how it works. When someone from Trimble, for example, says this is usually the way we store the data. This is a data set, share it with the group. Or someone from our domain team, if you say this is the formats we're working on, now's the chance to throw it in the middle and say, now you do something with it.
So the same would apply for example of AGS data or DIGS data. You know, when we will try to play with the association of external data into IFC concepts. Yeah. Okay. If no other question, then I think we should move on over to the concepts that we have selected for excavation support line. Maybe just one comment. What I really like about this typical section concept is that at the end, it's something that both geotechnician and civil engineers will share. and having a consistent way of describing what those typical sections are indeed, both from a geotechnical perspective and from a civil engineering perspective. That is, I think, very, very important. Okay, so
maybe we should mention also, just sorry, Michel, please. Of course we are, I think, as we speak, also regenerating the documentation,
right?
Which, as always, is linked then from the GitHub site.
Yes, absolutely.
Yeah.
Okay. Yes. So let's move on towards what we have for excavation support lining.
But Michel, you have set up another meeting for excavation, so we probably need to go out and in again. Or...
That is true. I have sent another link.
But no.
Yeah, we might want to do this. You're correct, Henrik.
Oh, I thought it's the same link for the full 1.5 hour. Oh, wouldn't even notice.
I did send 3 links, so let me check whether this is the same or not. It might not be the same.
No, I have only a Geo, so I have only 1 meeting.
Okay. I have 2 separate meetings, so
yeah,
because you are in two different groups.
So we should hurry that the excavation people don't disappear.
Indeed.
I'll drop and go right over.
Yeah, I think we should be doing this.
Could you share the excavation link again to the Geo group? Because maybe we
can,
don't
of
have
course.
It would be interesting.
Can, of course.
Perfect.
So we see you on the other side then, Michel.
Exactly. Thank you,
Bye-bye.
See you there. Bye.